Imagine we wanted to program a coffee maker that gives us our favorite cup of coffee. To build this, our coffee machine needs to know a 3-digit passcode that a user can enter into the coffee maker to get their favorite coffee. So let's say to get a mocha, we want to enter 512. For espresso, we can enter 345, and for latte, we can enter 444. Now let's get into programming this behavior. For our smart coffee machine, we wanted to check the value of an int variable called passcode and test it for equality against the list of specific values that it can take. We can program this behavior using a series of decision-making statements. Let's say we have access to our int passcode variable, but we aren't sure what value it will contain. We just know that it will be some sort of 3-digit number. We can then write an if statement and else if with test condition that checks if our passcode is equal to a certain value like 512 or 345. And then inside each statement, we'll assign that type of coffee to make. To keep track of the coffee name, we can use a string variable coffee type. And at the very end of our code, we'll print out the value of coffee type. So if we look at our first if in detail, it tests if our passcode is equal to 512, and we test for equality with this double equal sign, and the value 512 corresponds to mocha. If this test condition is true, we'll enter if block of code and set coffee type to the value of mocha. Then because we executed the code in our if, we'll skip down to the last curly braces and we'll just print out mocha. And the rest of this code works similarly. We check if the passcode is equal to 345. If not, we'll then check if it's equal to 444. And if it's not equal to any of these, our coffee type will be set to unknown. But this type of code can get really long for multiple passcode checks, and we are doing a similar check for equality in each of these test conditions. We are saying passcode equals some specific value, and Java gives us another way to write this code with a switch statement. A switch statement does the same thing but a little more concisely. It lets us check the value of a certain variable like our passcode and test it for equality against a list of possible values it can take like 512, 345 and 444. Each of these specific values is called the case, and we can program different behavior for each case. In Java, this switch statement looks like this. It's the keyword switch followed by the variable it wants to check for equality surrounded by parentheses. Then it has curly braces that will contain all of our equality checks, and our equality checks are just these specific cases, which here are the specific 3-digit passcode that our program knows. Our first if statement here will execute the same code as our case 512 here. The value of our passcode will be checked for equality against the number 512, and if it matches, we'll set our coffee type string to be equal to mocha. And that's the same thing we did in our first if. But if our passcode is not equal to 512, then we'll move on to our next case just like we'd move on with our next else if. And case 345 and case 444 corresponds to our else if code. This case checks for passcode equal to 345. If it is, we set our coffee type to be espresso. If it is not, we move on to our next case just like we move on to our next else if. So these three case checks for our three known passcode value, and if our passcode matches any one of these values, we'll enter the corresponding case code and set our coffee type to the correct coffee value. Notice that after each case is defined, like case 345, we write a colon and not a semicolon, and then the instruction we want our program to execute, which is to give a certain value to our coffee type string. And this is the format for all our cases. The word case, the specific value we want to check for equality, and then a colon, and then the code we want to execute. After each case, we have this word break. A break happens after code inside a case executes. It breaks out of the switch statement and goes to its ending curly braces. So having breaks after each case ensures that only one of these blocks of code will execute. This is just like how only one block of code in a series of if and else if will execute at a time. The break will break out of our decision making code and go to the end of the ending curly braces where it will print out the value of coffee type. There's also a default case that acts the same as an else statement. The default code will execute whenever other cases aren't met, like if the passcode was something like 914 and we don't recognize it or don't have a case for it. So both of these sets of code do the same thing. In fact, if our passcode was 512, the print output for both of these code would be mocha. For the code on the left, it would enter our first if statement and set the coffee type to mocha. And for the code on the right hand side, it would check the value of our passcode against our first case, and because these match, it would enter this code and set our coffee type to mocha. So switch statement can be implemented with if and else, but it can be easier and more understandable to write code in switch if we are doing a lot of equality checks. And as a programmer, it's really up to you to decide what to use to make your code easy to understand and use.